Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, I am Bambang Iswoyo. I come from Maksum University. I am here. I want to present our research with title Machine Learning Algorithm Optimization Bankruptcy Prediction of Bank at 2020, the first conference on the Internet of Things and Embedded Intelligence. This is my outline presentation. First given outline, introduction, data, proposed method, performance measurement, finding and result, and also conclusion. And then introduction. Financial distress occur in companies that are no longer able to meet debtor obligation due to lack of funds to resume business operation. Bankruptcy is defined the failure of a company to carry out its operation to generate profit. And then bank performance is monitored and evaluated using financial ratio indicator taken from the company's annual financial statement. Good financial ratio performance will determine the sustainability of the banking industry. And then Altman's model is an approach to predict bankruptcy using financial ratio. And then machine learning as an alternative model is widely used to develop predictive model in finance. Various approaches have been made to improve model performance. Ensemble learning is an algorithm that has been proven by many researchers to have better performance. And then the ensemble constraints that need to be handled are the first, a combination of variation in the classification algorithm that must be appropriate. And the second method for getting the output of the algorithm that are member of the ensemble. And the third, how to train its algorithm. And then there are the types of ensemble learning algorithm. The first, Bagging ensemble. Bagging ensemble is parallel ensemble method, where the best learn are generated in parallel. And the second, the boosting ensemble. Boosting ensemble is sequential ensemble method, where the best learn are generated sequentially. And the third, stacking ensemble. Stacking is a way of combining multiple models that introduce the concept of meta learning. And then objective my research. This study attempt to the first exploration of the performance of the supercapital machine, RandomForest, Logistic Regression algorithm in the financial sector for the classification of company bankruptcy. And the second, exploration of ensemble bagging optimization in the financial sector for classification of company bankruptcy. And then the model was developed using the Python programming language. The benefit of this model can be used by shareholders, management, and Bank Indonesia to monitor and evaluate banking performance based on the nature of the risk associated with the financial ratio. And then describe data for my research. The financial ratio database formed by a sample of 10 banks in Indonesian countries in the period 2011 until 2018 annual data. The database has 70 samples, 10 distress zone, 50 SVM sample and 10 Regression sample. And then feature to use my research, the first working capital to total assets, and then return earning to total assets. The next feature, earning before interest and tax to total assets. The fourth, book value of equity to book value of total debt. Next, Altman score and also labor class. This is purpose method. The first step, collecting financial report data from the website www.bi.id and or www.ojk.id. Process the data using the financial ratio formula Altman score. The second, preparing data for training data and testing data. The third, conducting an experiment in the classification of banking industry data using of the Logistic Regression Algorithm, support vector machine, RandomForest, and Ensemble bagging, Logistic Regression, support vector machine, and Ensemble bagging plus RandomForest plus support vector. The programming language by use Python. Step 4, report the result of the experiment using the 3 individual algorithm and 2 ensemble learning algorithm above. Altman score measurement for Peter were adopted from the banking industry report that is available in www.ojk.id. Those 4 features are in line with the requirement of Altman score. Independent variable CTA, rata, EBITDA, BFEBDTA. And then the 4 features are employed the independent variables predictors and the R match again to target variable Altman score and class feature. The class features are adopted as multi-class safe zone, gray zone, and distress zone. This is Altman score measurement. In general, score below 1.8 suggests a company might be ahead for distress zone, while a score below 3 suggests company in gray zone positioning, and score greater from 3 suggests a company in safe zone. This is Python coding to visually display a graph of the financial ratio dataset, where the x-axis is the independent variable consisting of VCTA, of WCTA, RETA, EBITDA, FBTDA, while the y-axis is the dependent variable consisting of safe zone, distress zone, and gray zone. And then RandomForest algorithm. This is the Python coding used to classify the financial ratio data set of the banking industry in Indonesia. In the coding, the R is common to display the level of accuracy in training data. data and testing data. The training data result in accuracy rate of 100% and 90%. While coding to perform the test data use confusion metric resulting in the value of precision recall F1 score for each defined or target variable, while the total level of accuracy get 90%. And then logistic regression. This is the Python coding used to classify the financial ratio data set of the banking industry in the Indonesia. And the coding tree is common to display. In the coding, there is common to display the level of accuracy in training data and testing data. The training data results in an accuracy rate XD 1% and XT%. While coding to perform the test data use confusion metric resulting in the value of precision recall F1 score for each dependent or target variable, while the total level of accuracy get XT 1%. And then SVM algorithm. This is the Python coding used to classify the financial ratio data set of the banking industry in Indonesia. In the coding, there is a common to display the level of accuracy in training data and testing data. The training data result in accuracy rate XT 1% and XT%. While coding to perform the test data use confusion metric resulting in the value of precision recall F1 score for each defined or target variable, while the total level of accuracy XT1%. And then hybrid logistic regression plus support vector machine. This is the Python coding used to classify the financial ratio data set of the banking industry in Indonesia. In the coding, there is a common to display the level of accuracy in training data and testing data. The training data result in accuracy rate XT1% and XT%. Hybrid logistic regression, RandomForest, SVM. This is the Python coding used to classify the financial ratio data set of the banking industry in Indonesia. In the coding, there is common to display to the level of accuracy in training data and testing data. The training data results in an accuracy rate 95% and 90%. While coding to perform the test data use confusion metric resulting in the value of precision recall F1 score for each dependent or target variable, while the total level of accuracy get XT 90%. And then hybrid RandomForest, support vector machine, and bagging Ensemble. This is the Python coding used to classify the financial ratio data set of the banking industry in Indonesia, where the hyperparameter of the Ensemble banking use RandomForest. Where the hyperparameter of the Ensemble banking use the RandomForest with initialization and estimator, then class weight, equal balance. Decision making use the hard plotting method. The training data result in accuracy rates at 93% and 95%. While coding to perform the test data use conversion metric, resulting in the value of precision, recall, F1 score for each dependent or target variable, man will the total accuracy rate in 90%. This is result comparison, random forest classification, logistic regression, spot vector machine, logistic regression, spot vector machine, hybrid, logistic regression, and random forest, spot vector machine, bagging ensemble, classification, random forest, SVM plus bagging. This is 90%, 61%, 81%, 90%, and the last 95%. Based on the result comparison table, it can be seen that the classification target is multi-class data, while the result of the statistical evaluation of the model get an accuracy rate of 95%, where the evaluated value are accuracy, precision, recall, F1 score. This shows that there was a very good increase due to ensemble modification. Result and discuss. The result of machine learning that employ ensemble learning bagging, hybrid random forest plus SVM show high potential for use in corporate bank distress finance prediction system, especially when it combined with knowledge of financial analysis. This paper strengthens research on the use of ensemble bagging that has been done by Barbosa et al. 2017 with accuracy in ensemble bagging 95%. Conclusion: this research was conducted to develop the optimization of the ensemble learning model for bankruptcy prediction, which refer to performance of the classification algorithm model based on the Altman Z-score formula. A combination of machine learning method of several classifier and the combined number of classifier method. The result of the proposed bagging ensemble combination model can improve accuracy, recall, precision, and F1 score by 5% to 14.7%. By testing using the same procedure, classification result gets 95% accuracy, while producing a stable solution that can handle overfitting, can overcome class imbalance, bias, and determine the appropriate hyperparameter for the machine learning environment. We use a collection of data on financial ratio of banking industry in Indonesia by having reliable model and indicator. policymakers can anticipate corporate financial crisis events. Finally, the proposed ensemble banking can be applied as an alternative to predict the bankruptcy of the banking industry. For future research, the modified ensemble model was developed into an integrated IoT system, where the system can retrieve the necessary data related to financial ratio from financial reports issued by bank registered with Bank Indonesia. In order to get the optimal performance from the modified ensemble model, it is recommended to compare it with other ensemble models such as ensemble boosting and ensemble stacking. Reference. Thank you for watching my presentation.